So some things here to chat about here. We're going to go through a bit of this worksheet here, number 5. I'm not going to do the whole thing for you, but we'll do a couple of problems of each of the types here to refresh our memories here a little bit. Just to let you know, this was the last homework assignment for this chapter. So I've posted the review and the key for the review. That's up there on PowerSchool right now. I made an assignment for the test that has on the calendar, and you can see a little description of like the kinds of problems you should expect to see on the test. And I have that scheduled for, is it the next class period? So that's Thursday, I think, for you guys. Okay.
Wait.
Yeah.
So our test is tomorrow?
Yeah.
Wait, the test is tomorrow. Wait, is it tomorrow?
Yeah.
Like, are you? I don't think
Tomorrow.
So rather than
it's fine.
Rather than complaining about things right now, let's focus on kind of clearing up some questions on things. Okay? So let's turn our attention to this. Okay? What would we like to start with? Dan? We want to look at number 3? Sure. So I'm going to need to use my graphing calculator for this at some point, so I'm just going to start by kind of pulling that up. All right. So it is recording. Okay. How many solutions would we expect to see in this problem? 7 solutions. Excellent. How do you know that there should be 7 solutions for this problem? Because it's the highest exponent in my polynomial, right? Okay. What I'm going to do now is I'm going to list my possible rational solutions. So the way I get those is I'm going to look at the factors of 16 divided by the factors of 8. So the factors of 16 are plus or minus 1, 2, 4, 8, and 16. But I also have to divide those numbers by the factors of 8. So I'm also going to have plus or minus 1 over 2. I'm not going to write down 2 over 2 because 2 over 2 is just 1, and that's already listed. Similarly with 4 over 4 and 8 over 4, or I'm sorry, 4 over 2, 8 over 2, and 16 over 2. Those are all already on my list. So I'm not going to write those down. I also have 1 over 4, but I'm not going to write down 2 over 4, 4 over 4, 8 over 4, or 16 over 4, because those are already on my list. And then I'm also going to have 1 over 8, but I'm not going to write down 2 over 8, 4 over 8, 8 over 8, and 16 over 8, because those are also already on my list. Everybody okay with that so far? So now I'm going to go and I'm going to look at the graph and see what I can learn by looking at that. So I'm going to go to the y equals menu, and I guess I'm going to just clear out all this stuff I have here. And I'm going to type in the problem exactly as it looks into my calculator. Very important that you're able to use your calculator to get a reasonable picture, because there's a lot of information that we can learn by looking at the graph. Okay, so I've got that typed in, so I'm going to go set a window now. So my x-min is going to be the smallest number from my possible rational solutions list. So that would be negative 16. And the biggest number from that list would be positive 16. And I'm going to, usually I have my y's at negative 10 and positive 10. I had been graphing something else, that's why they were changed in another class. So let's go ahead and hit graph and take a look at what's going on. All right, well, I see a bunch of crosses here, but it's too kind of, the graph is too far zoomed out for me to really get a good picture of what's going on. So I'm going to change my window. If I look here, it looks like everything is between negative 3 and positive 3. So I'm just going to go ahead and change my window to negative 3 and positive 3 and take another look at the graph. So when I look at the graph, I see x-intercepts at, well, it looks like negative 2.8. It looks like maybe negative 0.5. And then it looks like positive 2.8. Do you guys agree with that? Okay, so those are my real solutions to this, right? Approximately anyways, because I guess they're rounded at these since none of them were kind of going straight through a tick mark. Let's check to see if any of these are possibly irrational. The way that I can do that is I'm just going to check these x-intercepts against my list of possible rational solutions and see if that decimal or that number appears on my list. So negative 2.8 doesn't appear anywhere on that list, right? There's nothing really close to that. Similarly with positive 2.8. So I figure both of those are irrationals. But negative 0.5 is definitely on my list, right? That's probably my rational solution. Everybody okay with that? Next thing that I'm going to do is I'm going to look at how these x-intercepts are occurring. I'm going to look if they're bend, bounces, or straights, because that'll tell me how many times that solution might be used when I do my synthetic division. So negative 2.8 is passing straight through. 0.5, or I'm sorry, negative 0.5, that looks like a bend. And then positive 2.8 is going straight through. Okay. So I'm going to start my synthetic division, and I need to start it with the rational ones. So I have to use the 0.5 because that's the only rational solution. So for bends, how many times can bends be used? It's an odd number greater than or equal to 3. So it could be used at least 3 times, right? Could it be used 5 times? Yeah. Could it be used 7 times? No. Because I already have 2 solutions for the straights. If this was used 7 times, that would be 1, 8, 9 solutions, but I only have 8 solutions to work with. So it'd be too many. Everybody okay there? So I'm going to do this at least 3 times. After I do it 3 times, I'll look to see what I have left. And maybe we'll do it 2 more times after that. Or maybe I'll look and see something that I can factor. Who knows? Okay? But I know I'm going to do this at least 3 times. So I start by bringing the 8 down. Negative 0.5 times 8 is negative 4. And then negative 4 plus 12 is 8. And then we get another negative 4. So that's negative 46. That gives me positive 23. So that's going to give me negative 48. Half of that is positive 24. So that's negative 140. So that's going to give me positive 70. It's going to give me negative 128. Half of that is 64. That gives me negative 32. Half of that is 16. That gives me a remainder 0, which is what I was supposed to get. If I didn't get a remainder 0 here, it's likely I made some kind of arithmetic mistake when I did my synthetic division, because I know that this is rational, and I know it should work 3 times. If it didn't, there's nothing else for me to do. I have big problems then. So I'm going to continue and do another synthetic division. And that worked as well as I expected. So one more time, I know I'm going to do this. Is everybody okay to hear? Followed what I did? Notice how important looking at that picture was, though. That picture gave me a lot of really important information, right? It told me which of these x-intercepts to try to use. It told me how many times I should be able to do that synthetic division. And now I'm going to stop here. The reason I'm going to stop is because of the form of these numbers. Notice how I really just have 3 numbers here because of the 2 zeros in between. Everybody see that? This is something that's in the quadratic form. So it's likely I'm going to be able to factor this without having to do any more synthetic division. So I'm going to stop here and write down what I really have. So I have x plus 1/2 3 times. Is everybody okay with how I got that? Each time one of these gives me a remainder 0, it creates a factor. So because that division worked 3 times, I get 3 of those factors. And the sign is always opposite. Okay? Now I'm going to include this piece down here. So remainder, remember this first one is the remainder, then it's a constant term, x, x squared, x to the third, x to the fourth. So I have that polynomial there. Is everybody okay with that? If I look at that polynomial, 8x to the fourth minus 48 squared, or 48x squared minus 28. I notice there's a greatest common factor there. There's an 8 in both the 8x to the fourth, the 48, and the 128. So I'm going to factor that 8 off. What is that? That I should be able to do that in my head. Is it 32? I think it's 32. Let's double check real quick. Nope, 16. Okay. Everybody's okay here. So we already established that this guy is in the quadratic form because this exponent is twice this exponent. And then I have a constant term at the end, right? That's what we said the quadratic form was last semester when we factored these. So all I really need to do is find 2 numbers that multiply to give me negative 16 and add to give me negative 6. What are those 2 numbers that do that? Negative 8 and positive 2, right? And normally when we factor these, we would put x's there. But because my middle term was x squared, these should really be x squareds. Right? You kind of remember that from last semester. Hi. All right. So there's one thing left to resolve, and it's the fact that this guy has this fraction inside of it. Right? Here's how we're going to deal with that. 8 is really 2 to the third. Everybody agree with that? Because these exponents are the same, I can distribute the 2 in without having to deal with the exponent. If the exponents are different, you can't multiply them together. But if the exponents are the same, you can multiply them. This should make sense because if I just take 2 times 3, they're both to the first power, I can multiply them together, right? If I have 2 squared times 3, I can't multiply the 2 and the 3 together. I have to do the exponent first. But if the exponents are the same, it's okay to multiply them together. So I'll just distribute the 2 in, and that's going to give me 2x plus 1, everything still to the third. And now this is completely factored. So all I'm left to do is to set each of these factors equal to 0 and solve. So when I subtract 1 and divide by 2, I get 1/2. Subtract 1 and divide by 2, I get 1/2. Subtract 1 and divide by 2, I get 1/2. Add 8 to both sides. And then when we square root both sides, we create a plus or minus. Subtract 2 from both sides. When I square root both sides, I get a plus or minus. But I don't want to have the square root of a negative, right? What happens when I have the square root of a negative? Makes an I. So those are my 7 solutions. Grace? Why is that 1/2? I subtracted 1 and then divided by 2. To just solve for x. Is that okay? Okay. Should we do one of 4, 5, and 6 now? Okay. Do we have a preference there on which one to do? I just heard mumbles. I don't know if anybody feels strongly with 4. Okay. Well, we can start with 4. We can probably do 6, though, also. Okay. So the first thing I'm going to do is, if I want integer coefficients, I have to make sure that I follow the irrational conjugates theorem and the complex conjugates theorem. What those say, the irrational conjugates theorem says a polynomial with integer coefficients has a irrational solution if and only if those irrational solutions occur in conjugate pairs. So the first thing I'm going to do is I'm going to look at my list of solutions that I'm given and see if there's any irrational solutions on that list. I see one. The square root of 5 is irrational. So I should also have the conjugate to the square root of 5 on my list. What's the conjugate to the square root of 5? It's just negative square root 5. The complex conjugates theorem says something similar. It says a polynomial with integer coefficients has imaginary solutions if and only if the imaginary solutions occur in conjugate pairs. Do I have any imaginary solutions on this list? No, right? Because there's nothing with an I in it. So that doesn't matter to us. Okay. Next thing that I'm going to do is I'm going to go and I'm going to take each one of these solutions and convert it into a factor. So the solution x equals 1 turns into the factor x minus 1. The solution x equals 2 turns into the factor x minus 2. The solution x equals negative 3 turns into the factor x plus 3, etc., etc., etc. Everybody okay there? So the last thing I need to do is to make sure that my factors have integer coefficients. So x minus 1, great, everything's an integer. X minus 2, everything's an integer. X plus 3, everything's an integer. But x minus the square root of 5 and x plus the square root of 5, those aren't integers. So to fix this, I'm going to take this conjugate pair, and I'm just going to multiply those two things together. So I'm just going to FOIL that out. When I do that, I get x squared minus x square root 5 plus x square root 5 minus the square root of 5 squared. Notice that when I combine the like terms, I have x root 5 and negative x root 5. When I combine those together, they cancel out and give me 0, right? Also, I have the square root of 5 squared. What is the square root of 5 squared? It's just 5, right? Because the square root of 5 squared is the square root of 25, which is just 5. Or you can think about the squared canceling the square root. Either way of thinking about that is okay. So we're left with that last factor, just x squared minus 5. And because we didn't do anything extra that we didn't have to do, we have the minimum degree requirement, so this is our final answer. Everybody okay there? Questions on what I did or why I did things there before we go on to the next one? Should be doable. Those shouldn't be too bad, right? That first one wasn't too bad. Okay, you guys said you were also interested in 6. So let's do that. So I'm going to start the same way with the integer coefficients. I'm going to go through my list and see if there's any irrational solutions. There's not, but there is an imaginary one, this guy right here, right? So I'm also going to need its conjugate on this list. What is the conjugate to 1 minus I root 2? It's 1 plus I root 2. Everybody's okay there? Okay. So I'm going to now convert each of these factors, or each of these solutions, into factors. So that factor becomes x minus a half. This factor turns into x plus 3 halves. And then I have x minus 3. And then I have that 2 times 3 times. So I'm just going to put an exponent of 3 there. You could write it 3 times, that's fine. I'm going to do that instead. And then remember when we did this on Friday of last week, we talked about how when I have something that looks like something plus something or something minus something, I'm going to move it over as one big piece. Now, you could move it over as two separate pieces. That's fine. It makes the multiplication later a little bit more tedious to think about it as three things rather than two. But it's not wrong. Everybody okay there? So far, so good? Okay. Next thing I'm going to do is check to see if I have integer coefficients in each of these factors. So I look at the first factor, x minus a half. Oh no, I already don't have integer coefficients. So what I'm going to do to take care of that is I'm just going to multiply that factor by 2. Because when I multiply the 2 through, it's going to get rid of the 1/2, right? If I look at x plus 3 over 2, oh no, again, I don't have integer coefficients. Well, to fix that, I'm just going to multiply that factor by 2. Again, when I distribute the 2 through, it's going to get rid of the 3/2, right? X minus 3, that's fine. These two, because they're conjugate pairs, I can just multiply them together and FOIL out, and that'll take care of that. So I'm going to distribute these 2's through. And then I FOIL here, so x times x is x squared. And then I have negative x times 1 plus I root 2. Then I have negative x times 1 minus I root 2. And then I have negative times negative, so positive 1 minus I root 2 times 1 plus I root 2. And then here I'm just going to distribute those x's through. And then I'm going to FOIL that piece. So these first three factors, nothing's going to change for. When I distribute this through, I have a negative x minus x I root 2. Then I have a negative x plus x I root 2. Plus, and when I FOIL this, I have 1 plus I root 2 minus I root 2 minus I squared square root 2 squared. So when I combine some like terms, notice I have a negative xi root 2 and a positive xi root 2. Those cancel out and give me 0. I also have a positive I root 2 and a negative I root 2. Those combine to cancel out and give me 0. Then what is I squared equal to again? It's equal to negative 1. And what's the square root of 2 squared again? Just 2. Okay. So when I now combine, I have an x squared. I have a negative x and another negative x. That'll give me negative 2x. I have a 1 minus 2 times negative 1. Well, negative, or 2 times negative 1 is negative 2. And 1 minus a negative 2 is positive 3. So, oops. So that's that. We still have 2 more things to worry about, though. We need a leading coefficient of 12. Right now, what's my leading coefficient? It's going to be 4, because I'd have 2x times x to the third times x squared. So it would be 4 would be the leading coefficient. So to make the leading coefficient, or get the leading coefficient up to 12, I just need to multiply by 3. Because 3 times 4 is 12. Okay with that? Now, it also asks that I have no constant term. Grace? That was the requirement in the problem. It says the leading coefficient to be 12. It also asks that we have no constant term. Right now, do we have a constant term? Sure we do, right? It's going to be whatever. It's going to be, it'll be like 3 times 1 times 3 times 27 times 3 again. So I don't know, like 729 or something horrible. Doesn't really matter what the number is. Does anybody remember the way we get rid of the constant term? It's an easy fix. Not divided by x, multiply by x. So instead of this being 3, let's just make it 3x. And now we're done. So to get rid of a constant term, you just multiply by x. And no more constant term anymore. And because we didn't do anything more than we had to, we still have the minimum degree part. So that's fine. Tom, do you feel better on that?
No.
Okay. The worst part is when you have one of these things, the foiling just gets pretty obnoxious, right? Four wasn't too difficult, right? The difficult is when you have to do that extra, like where it turns into 2 foilings. There's kind of a lot of crap going on. But if you just write it down and you go slowly and be careful, it's not too terribly difficult. It's just kind of tedious, right? There's a lot of writing, a lot of stuff to keep track of, but not too terribly difficult. Okay. Do we feel a bit better about this assignment? Help review going through how to do these things? So again, if you go and you look at our PowerSchool page, you'll see the Chapter 6 review is posted. What the review looks like is this. So you're going to have one problem on your test that's kind of like number 1. And this should be something that's pretty easy to do, right? You have one problem like number 2. So I'll give you some information about the polynomial. So I'll tell you the solutions, the possible rational solutions, and then the picture, and ask you some questions about that, just like we did on the homework quiz, right? Okay. Then you'll have one question like number 3. So I'm going to give you the polynomial and tell you the information that I got from the graph and ask you to factor it. So just do the synthetic division. I've already gone and looked at the graph for you, so you don't need to graph it yourself. I've told you the number of solutions and whether they're bend or bounces or straights. So all you have to, and if they're rational or irrational. So all you have to do is do the synthetic division to get to the factored form. And then you'll have one problem, or this is still part of this one, although they're not related. Here I've given you the polynomial in factored form. So I'm done with my synthetic divisions. And I'm going to ask you to solve this and write down your solutions in exact form. So between these problems 1, 2, and 3, what we've done is the full solving problem, right? Now we did it for different little parts where I've gone in and filled in some of the gaps before and afterwards. So I can try to isolate, do you know how to do like this part of the solving process? Right? Does that kind of make sense? Okay. And then then I ask you to solve 3 polynomials just all on your own, where I don't give you any information other than the polynomial itself. So that's doing like the full procedure, like 1, 2, and 3 from the previous homework. Or if you just followed the outline that we kind of made from those previous problems, that's basically what we're doing. On your test, you'll have one of those to do, right? Because those are kind of time consuming. Everybody okay with that? And then the last 3 problems on the review are just like these last 3 problems from the previous homework, where I give you some criteria and ask you to write the polynomial that meets those criteria. And you'll have one of those to do on the test. Everybody okay with that idea? So again, if you go to the Power School page and you looked at the test assignment, again, that same information that I just went over here aloud for you guys is on your Power School page as well. If you go to the calendar, excuse me, it's on the calendar. Okay?
Maybe we'll test it Monday.
No. So you guys, most of us have worksheet 5 things to finish up. Okay, so if you weren't able to finish that, you have, I don't know, we have 25 minutes or so. You guys should start working on that. If you finished that, or were able to finish it after seeing some of the examples we did in class, start in on the review. So if you go to the Power School page or go to the calendar, the review is in both places. I have the key posted along with it with the worked out solutions. So if you looked at the key, you have me going on and like being pretty thorough and working out solutions for it. On this one, I even tried to color code things with like what I was doing. So that's kind of nice. Like what parts, what numbers or things come from which one of these criteria that I was trying to do. So, okay. So you can certainly check things. I'm available, obviously, during community times. You know, if you have to come in and talk to me about something, or if you're not sure on something or need to go over something again with me, I'm happy to do that. Okay? But you guys should spend the next 25 minutes or so getting caught up on whatever it is you need to be working on. Okay? So come bother me if you need something. If not, make sure that you kind of go through the review carefully for the test Thursday. Yoo-hoo. Yoo-hoo.